All right, folks. Let's do another 2.5 example. So this is more function translations. And what I'm going to do is I want to get us through a few different translations kind of all in a row, but I want to do it in stages. So what I've kind of prepped is 4 different graphs. So we'll actually, go from one version of a function to a translated version, and I'm going to set up essentially 3 different translations to do. We'll graph them, obviously, but I'm also going to sort of track the different moves of the XY coordinates on a separate sheet. So we're going to try to keep, metaphorically, a couple different balls in the air. We'll see if we can make this work. So here is our original function, f of x. What I'm going to do is I'm going to sort of identify a handful of key points. So this is sort of corner points in the function, the sort of obvious whole number points. This is sort of a parabola-ish kind of thing, and then it curves again. So we're on our way to making sort of a McDonald's type arch or something, and we just sort of stop once we're a little bit past halfway. This is fine. This is just a generic curve. So what I'm going to do is I'm going to label a couple key coordinates. So a couple key x, y values. And so I'm going to list them here, right? This y value is, of course, our f of x value. And then as we do the translations, we'll sort of change the different coordinates, either the x coordinates or the y coordinates, depending on what we're doing. So let's just go from left to right. The first one will probably be this, our sort of left endpoint. So this is -2 in the x and -2 in the y. So this is sort of -2, -2, right? The next one maybe, I guess, is this guy. So this is sort of -1 and 0. Got our y-intercept at 0, +1. Fit these guys in. Then we're going to go down, right, to sort of +1, 0, and then up and over to +2, 1. So 1, 0, and then 2, 1. So this is our sort of starting point. This is our sort of original function. Our goal is going to be to graph, what should we do? How about, let's do the negative version of f of 1/2 x, and let's subtract 2. So the negative version of 1/2 x, and then the whole thing is -2. So what we're going to do here is we essentially have 3 different translations happening. So we have this sort of 1/2 times the x value. That's going to be a horizontal stretch, right? Because it's a c value that's between 0 and 1, and so it's times the x, which is going to stretch us out and make it wider. We've got a negative in front of the whole thing. That's going to be a reflection over our x-axis, so that's going to flip us sort of top to bottom. And then we have this -2 as the last thing, so that's going to drop us down 2 y units. So let's do this in stages. I'll kind of color code this as per usual. So let's do f of 1/2 x. So this is horizontal stretch. And so what happens here is x values, right, get divided by 1/2. If we divide by 1/2, though, that's the same thing as multiplying, right, by 2/1, which is going to be multiplying by 2. So what's going to happen is we're going to double all of our x values. And what I'll actually do here, how am I going to fit this in? I'll make a new table. We'll go x, we'll go f of 1/2 x. So what we're going to do, rather than necessarily just do this visually, of course you can do that like we did in the last example. That's totally fine. But what I'm going to do is I'm just going to do this strictly on a table. And what's going to happen here, right, is we're going to change our x values. We're actually going to keep the y values the same. So before I do anything else, just to kind of emphasize that, I'm going to sort of rewrite all of our different y values, right? So these are the pairs, right, that are our coordinates. So that's here, 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 and here. That's sort of our points, like A, B, C, D, E or something, if we wanted to label them. And so what I'm doing is I'm going to multiply all the x values by 2. I'm going to double all the x values. So for example, right, where the x is -2 and the y is -2, so the new x value is going to be -2 times 2 is going to be -4. So -4, -2, and if I graph that, right, 1, 2, 3, 4, and then down 2, that new coordinate is going to fall there. So I used to be back here, and I'm essentially shifting over twice. My new value is here. We'll keep that going. -1 times 2, obviously going to be -2. 0 times 2 is 0. 1 times 2 is 2. 2 times 2 is 4, right? So we've essentially doubled all the x values. That takes our graph and it's going to expand it, right, from left to right. We're kind of centered in the middle, so the middle stays fixed and we're sort of moving outwards from there. So this is -2, 0. So that's going to go through here. That used to be this point, right? So now it's here. We're going to have 0, 1. Actually stays the same, right? Because if I multiply x equals 0 by 2, I just get x equals 0 again. +2, 0 is going to be here, and then 4, 1 is going to be here. And what I'll do is I want to connect, right, all of these dots, and I want to try to keep the same type of behavior that I have here. I want to sort of write this as a smooth curve as best I can. Let's give it a go. We're kind of going something like this. Up. This guy comes down. And this guy comes back up. So you can see it kind of roughly keeps the same shape. So this is f of 1/2 x. So it more or less keeps the same shape. It's just been sort of expanded from the center. All of our points got sort of shifted away from the axis, away from the y-axis. So that's step 1. We're going to pick up with this in the next video, so it's not too long at a time.